We'll be continuing our talks now. Next up, we have Nenad Mijatovic, Director of Data Science and AI at Alstom, and his topic is Building Trust in AI, Alstom's journey towards safe, reliable mobility solutions. Nenad, you may start.
Thanks so much. So first of all, thank you guys for organizing this. Thanks for inviting me. I'm super excited to be here. Originally, I'm from Belgrade, so and this is my first talk in my city, so I'm very excited about that. So in the next 20 minutes, I'm going to talk about what we do in Alstom, about the data science and AI. Now, guys, is anyone aware what we do in Alstom? Okay, a few, all right. So I hope good feedback, good experience, but really what we do is we build trains and we build systems. So we build basically all the infrastructure which will allow you to move from point A to point B, as a person, as a staff, whatever, okay? That's what Alstom do. Very briefly, over the boring numbers, we have a little bit more than 85,000 people. 1/4 of us are engineers, and we have more than 250 projects in the world. Okay, so we are the biggest mobility company on the planet. What is interesting is that we operate in 64 different countries, and there is a vast majority of the people coming from different walks of life, and I'm super excited to be part of that group. So now, the next thing about me, so Nenad, I'm really honored to lead the data science and AI in Alstom on a global position, and whatever I'm going to talk about in this talk is basically related with the work of my team, so I'm super proud of that. Before Alstom, I was working for little of startups. I was part of the GE Transportation. Then I moved into Alstom, and now I'm based in Paris and having a team of about 250 people. I like to say that we're all over the place, but in a good sense, because I have folks in Paris, in Spain, in India, in Singapore, in Brazil, and I hope we might have something here in Belgrade, right? Anyway, so again, what is extremely important for you to get from this slide is that we are moving people in a safe, efficient, and very, very reliable way, okay, secure way. So why that is important? First of all, you guys all know energy is critical nowadays, and you know that the rail is the most efficient way of moving stuff around, right, with something what is called engine. Otherwise, you walk or you pedal. Not so much fun. But what is stressed here that I would like to mention is that is a safe way. Okay? So majority of our business is making sure that you guys are safely moving from one station to another station. And there is a lot of complexity, a lot of systems around that which enables that, right? So if you guys know, the railway is one of the industries having the least number of incidents among all ways of transportation, and we're super proud of that. Now, why I'm here? First of all, what I want to say is that when we build the data science and AI in Alstom, we build it in something what we call the non-safety critical application. In other words, whatever I said before about safety, right? AI cannot be used for safe applications, okay? At least not for now. And the main talk and the main emphasis of this talk is, how we can make even the safety critical applications applicable for us. So right now, my team is involved in almost all non-safety critical applications, which are only 20% of our business. And we want to expand that. Okay, does it make sense? Cool. So how we can do that? First of all, trust, right? So you guys start using AI. Someone is, super careful, someone trusts, someone doesn't trust, I like ChatGPT, you don't like ChatGPT, whatever, right? That's not the point. The point is that, like with any other new technology, you need to build trust in that technology, okay? And first of all, we build trust internally for our people. Because as you guys mentioned, we build the tools for our internal métier. So we needed to make sure that when we build something, that our métier will trust our results and also how these algorithms came to the final conclusion. So that is the internal. The second one is whatever we do is we sell the stuff, okay? So we want to build the trust in our customers when we're selling our solutions. So that is the big emphasis that we do. And finally, whatever we do, right, we are living in a world where there are some rules and laws, right? So we need to take care of the regulations. And that is where we're involved as well. So you guys know that there is across the globe a lot of different initiatives to put the AI to be, regulated in a different shapes and forms. So from the Canada, the States, Australia, China, and now to the EU. Where are you going, guys? We're just started. So, all the way to the EU, recently EU Act, we put a lot of regulations around the AI, so you guys can trust that not only because I'm, great and I believe that my algorithm is best in the world, but because I prove you that that's the case. Okay? So how do we do that? We have 7 different pillars which allow us to provide the trustworthiness in our solution. First of all, we need to make sure that when we develop our algorithm, the algorithm will be robust enough. What does it mean? Well, that means that when we, for example, detect signal, that detection will be reliable regardless on the condition that signal might be available. So you can think of a sunny day, you can think of the lightning, you can think of, fog, whatever that might be, okay? The next one is the resilience. So what does that mean? That means that, in whichever condition you put my algorithm in, it will be reliably, reluctant on any different disturbances. And that is extremely hard thing to do, okay? So you guys, I'm not sure if you listen, but there is a lot of, talks nowadays where you can change just a little bit the image, just put a random noise, really nothing that for us as a human beings is still you can say that this is a signal versus this is not a signal, where only the small disturbance of that signal, right, that picture, that image will basically fool the AI algorithm, in a completely different direction. The next one is secure. What does that mean? So that means that, whenever I put the algorithm in any different condition, it will basically be resilient on any attack or any basically noise that I just explained to you, right? And I'm going to the next topic, which is related with explainability. When we started, this journey in Alstom, we were so proud and we knew how every single algorithm worked, but the experts asked us, okay, but how did you get this result? Can you explain to me, what are the path how this algorithm came to the final solution, right? So that's one, basically how the algorithm provides the result. The second one is interpretability of the result itself. So for me, as a data scientist, if I say, okay, this signal has a mean value or whatever, that means something to me, right? But for you guys or for métier who is using that information, doesn't mean anything. So you need to be able to, put that result in appropriate format so then it will be interpretable by the final user. The next one is fairness. So you guys are all aware that there is a lot of biases in AI. Why is that happening? Because the data which is coming from and you're feeding the algorithm might be completely different, right? It might be biased towards one group versus another. In my particular case, that's a little bit different because if you guys remember what I said at the very beginning, we're super proud of not having, incidents, right? Incident is a data point that I'm about to analyze, right? So I don't have enough data points, meaning that my data set by natively is biased by default, okay? So in my particular case, it's not that we're only thinking about GDPR, for example, but also the biases within a data set, meaning that I don't have so many interesting data points as a data scientist to use, right, is a big, big issue. And finally, that is the safety. So when we need to put our algorithm, we need to make sure that that algorithm will not do something stupid. In other words, something unsafe, right? Cool. So guys, this is one of our trains. And basically, this example showcase in how many different use cases we do have AI and data science involved. Traditionally, we started with something what is called predictive maintenance. Do you guys know what is a predictive maintenance? Kind of, right? Okay. Do you want to answer? Do you want to? No? Okay. So this is the predictive maintenance. Basically, what we do is we build trains, right? So we get a lot of parts, let's say brake, filters for AC, seat, even part of the engine. Doesn't matter, right? And with every single part, we get, like you guys have in a cars, right? There is a certain warranty for that particular part. Let's take HVAC as an example. So AC. So have you guys ever changed AC in your car? Do you know where it is? Right, it's super simple, right? I mean, anyone can do it, even me, right? So you just take it out one, put another one, all good. But sometimes you guys probably know that you usually change that filter only when it's super dirty, right? When it's like, okay, the lights are red and you need to stop and car is not running, whatever, right? That is exactly happening with the train. However, this is cool. If AC is not working on this train, the train doesn't go, okay? So in your car, okay, you might be frustrated, but in our particular case, if the train is not going or it's stuck, meaning that the riders are super mad, the customer is super mad, calling our CEO, having a nasty calls, and then we are in trouble, okay? So bad situation. So what we do is we analyze the status, the health of that filter, okay? And then we predict when that filter is going to go bad. And then based on that, we suggest that that particular filter, that particular train, should be sent to the depot for the maintenance, okay? Super simple? Cool. However, it's one of the hardest problems in data science and AI. So prediction when that filter is going to break, it is super hard problem because it depends on operational conditions of the train, how many times that train was driven, who drove the train, is it automatic or not, etc. So that's the first application. The second application is something what is called odometry. Do you guys know what is odometry? Okay, I didn't know. Basically, for me, it was like, this doesn't make any sense, but basically, the train must be known where is the position of the train in any single point, okay? All right, it's very kind of simple problem and task, but extremely hard to do. So any issue with odometry system, which is a critical system on the train, will cause a train to stop. So my team is analyzing data from odometry to figure out what is the problem with this odometry system, if any. All right, so let's move on. The next one is we guys tend to reuse the data set. What does it mean? That means that some of the systems which are traditionally used for one of the applications, right, we are trying to find yet another use cases for the same data set. An example is the following. We have a lot of cameras right now which are put in the trains, okay, as well as on the stations. Why these cameras are used? They're used to detect if there is some physical security issues on the train, okay? If something is fighting, or in the case of the incident, the police and the government and authorities can understand what the problem was on that particular mission. And we said, okay, that's awesome, but we can also do the same camera, first of all, to understand what is the number of people on board. Okay? So how many people are on the train? Why that is important? That is important because if I know how many people are currently on the train as well as their distribution, we can adjust our automatic train system, for example, to provide the specific service, which will again reduce the energy used for driving the train. Okay, does it make sense? The second application is this, right? Hopefully, in a couple of years, we're going to have trains here. One of the problems is that at the terminal stations, right? So the last station of the line, there was one funny story. So my office is at the last station of the line 14, which is automatic line in Paris. All right? And once I was boarding the train, because it is the first station, and there was a guy inside completely freaked out, because what happened is, he didn't realize that was the last stop, so he went in a depot. He was stuck there for a couple of minutes, hours, whatever. It looked like the whole century for him. So he was completely, stressed out. So what is the point of the story is this, right? It is super important for us to understand if at the terminal stations there is a person, or luggage left, based on which we can, alert the operator that something is wrong. All right? If you guys leave your luggage for any reason at the last terminal station in Paris or anywhere worldwide, the operator will call police to check on that bag. So that means at least, in best case scenario, 35 to 1 hour train delay. And our system basically, why our system is important? Our system is important because we automatically do that with existing data set. So we don't install any additional equipment. Does it make sense? Cool. We do everything through something what is called our maintenance system. And you can think of a bunch of different sensors, LiDAR, cameras, vibration sensors, temperature, blah, blah, that we run the train through. And then my team is developing algorithms to detect issues on the train. Next one is something what is called the signaling or infrastructure. So infrastructure is rails, right, as well as the switches, which allow the train to go from in this direction or that direction, right? Super simple. However, it's also the critical piece of infrastructure, because if something is broken or if the switch machine is not working, the trains are not moving. Okay? However, if you guys, is any of you guys claustrophobic? Okay? Yeah. Thanks, friend. So I am, right? So and just imagine, any of these kind of maintenance stuff is done overnight under the ground. And usually it's only 1 or 2 guys, right, going to fix the stuff. So what we do, guys, and that's kind of super cool, is we are helping these people to really pinpoint exactly what the problem is. So we tell them exactly where they should go and what should be fixed. Okay? All right. So the next one is related with track circuits. Track circuit is kind of also the super cool, interesting application, because the track circuit is something. And again, for me, it was incredible, is how you don't know where your train is. I mean, that doesn't make any sense, right? But really, locating the train within the system is very, very hard to do. So what they do is they have, in some particular implementations, they have something what is called a track circuit. Track circuit is the piece of rail, say 500 meters, a kilometer, in a freight stuff, might be even 5 kilometers, right? Within which we can locate the train. The train is in. But it's just the binary information. So the train is in or train is not in. That still doesn't mean that, there is, where is it within that 200, 500, meters. So what we did is We use the data they send for the signaling information from one end to another end of the track circuit, and we look at the shape of that signal. Okay? And the shape of the signal basically has embedded information about condition of the track. Another one, again, example is, we're super proud of that, we're reusing the same data set over and over again for different use cases. And this data, guess what? They're coming for free. So the only thing what we invest here is we invest our domain knowledge as well as our data science and AI knowledge. Cool. So it's great to be part of this. And by training, I'm a data scientist and machine learning guy. Okay, I'm not coming from the industry, so. And if what is super cool is I have a lot of toys to play with along with my team, right? And we can have a very comfortable life, right? Alstom is paying us. We feel comfortable. We come to the conferences. We talk, blah blah. But that's not the point. The point is that we are here really to help the business and help you guys. So whatever we do with any, I'm super proud of you guys. Probably you guys heard people here talking about, okay, 1 of 10 data science and AI projects are successful and all of them die, yada, yada, yada. Okay, great. What we do is we do stuff completely differently. We act as a startup within the company, and we start with the business use case, okay? So you need to come to me with the data, with the métier, with the problem, with also the business case. And only then we can talk data science and AI. So first of all, we, as the company globally, we're planning to cut all CO2 up until 2050. All right? So 0 CO2 emission. The second one is, right now, as we speak, although we are, energy efficient company, we want to do the next step. And by the way, thanks for that. I'll have one more talk this Friday, and I'm going to specifically talk about use cases. One of them will be energy. So please come over, 10 a.m. There is nothing better to do on Friday morning. So right now, what we do is we cut the energy of consumption of our solutions anywhere between 7 to 15%. So on an existing system, the way how it is, using the existing data, we're still, with the help of the data science AI, we can reduce up to 15%. We help our maintainers, right, to basically reduce overall maintenance activities by 20%. And we cut significantly the number of unnecessary checks during the maintenance period by 1/4. And guys, just imagine how frustrated it is if I go back to the example of this poor, guys who are doing the maintenance. They need to go in at 3 a.m. in the morning with heavy equipment underground to change something, and they say, no, this stuff is working. I'm here for nothing, right? The guys will not be happy. So what we do is we are very, very reliably, improving the operations of our systems. Cool. What is next? Oops. So overall, what is important to say here is that, we believe that we are great as the company. We have a purpose. Everything is perfect. However, have a lot of talented folks, but we are not alone in this journey. So in order to bring the trust in AI, we cannot do it by ourselves. So what we do, and I'm super proud of that, we're collaborating with the academic institutions, with other companies, which are having the similar purpose as ours, and we're building the trustworthy AI applicable for the mobility. So if you guys are interested, please, reach out to me, and thanks for your attention.
Thank you, Nenad, for your presentation. Here is a little thank you from us.
Oh, thank you.
We do have time if you guys want for a question or two. I think we have first row here.
Yes, thank you for the presentation. Fascinating. Since this is such a high security application, because there can be no room for any kind of error, do you guys, I'm curious, use formal verification in your systems?
Yes, yeah, that's excellent question. So basically, yes, we just recently started using the formal methods for the making the resilient part of our algorithms. Yeah. Are you guys doing the same or?
I used to be doing that
But
at
for
Intel.
software, right?
No, actually for hardware in '94. So.
Okay, cool. So definitely your experience will be interesting to understand. Okay, cool.
Next question over there. Look to your right.
Thank you for your interesting story. You were talking that there is not enough data according to the bias, real adverse events. Are you using any synthetic data to simulate these adverse events?
Yeah, that's a good question. Again, making the synthetic data in our systems is super, super complicated because the complexity of the overall system is not easy to make digitalized. Okay, so we have a lot of we had a lot of attempts to make like a digital twins, and right now we are kind of not going that route. We are digitalizing every single component of the train with the desire to make the whole system as a digital twin. Does it make sense? And then based on that, we can build this kind of events, right? However, I'm talking here about catastrophic events, okay? And this will be still hard to make. There are some events, some other events that we are generating, and that is when you're putting the system under different operational conditions. And that is something what cannot be done easily on the field. So example is that, let's say that, example next Belgrade Metro, right? So they will not be able to test all possible conditions, right, where this train is going to go from point A to point B, okay? So what we do is we're using the mix between simulations as well as the data science. As a matter of fact, right now what we're doing is we are generating the synthetic data is very expensive as well as lengthy process. And you need to have extremely good guys who understand the physics of the phenomena. So what we do is, we create specific design of experiment, which will give us only the specific data points, and then we use the AI to basically recreate all other possible outcomes and conditions. Does it make sense? Yeah. You're welcome.
We have time for one more quick question, if there is any.
So everything was clear?
Okay, in that case, thank you again, Nenad, for your amazing presentation.
Thank you so much. Appreciate it.